All right, so what we're going to look at now is segment proofs, okay? This is very similar to when we did the algebra two-column proofs, when you had to prove a given statement. Maybe it was we had 2x plus 5 equals, 20, and we wanted to prove x is equal to some value, okay? It's a similar idea to that. Now, in order to work through these, you guys are going to need your theorems and postulates and definition notes on hand, okay? Because we're going to refer to those when we prove this, okay? So remember, when we prove something, we have to use what we already know in order to prove something new. So we're going to draw upon those statements that we have made earlier in your notes to help us work through these. Now, there are only 5 questions on the in-class examples, so I'm going to work through one of these, and then we'll work on the other 4 together in class, and then you'll have time to work on the concept check. Okay, so the one I want to work on in particular is number 4. So if we look at number 4, it says if A, B, and C are collinear, they lie on the same line, then the length AB is equal to length BD, and length BD is equal to BC. Then B is the midpoint of AC, okay? So let's just think about what we're trying to prove for a second. We're trying to say that this point B is in fact the midpoint of AC, okay? So that's what we're trying to prove. Now remember, we always start with the information we know, and that's the reason we start with that is because it's given to us. It's given to us. So we know that A, B, and C lie on the same line. We know that the length of AB is equal to the length of BD, and we also know that the length of BD is equal to the length of BC. Okay, that's what was given to us. Okay, then on step B here, on statement B, it says segment AB is congruent to segment BD. Well, how do we know that? Well, we know by the definition of congruent segments, if 2 segments have the same length, they're congruent to each other. And we were told in our given statement that those 2 have the same length. And it's the same argument for this guy. BD is congruent to BC because BD and BC have the same length. So our reason here would be the definition of congruent segments. Okay, definition of congruent segments. Now on statement C, it says AB is congruent to BC. Okay, well, how do we know that? Well, think about your transitive property. This says AB is congruent to BD and BD is congruent to BC. Well, then by the transitive property, doesn't that mean that segment AB also is congruent to segment BC? Yeah, and that's that T3, that theorem 3 property that we looked at that said congruence of segments is transitive. Okay, so remember, if A equals B, B equals C, then A equals C type thing. Okay, now on statement D, it says AB, length AB is equal to length BC. Well, how do we know that? Well, we just said that segment AB is congruent to segment BC. Well, if those 2 are congruent, they have to have the same lengths. Why? Because that's the definition of congruent segments, okay? That's the definition of congruent segments. Okay? Now, once we know that, we're saying that AB and BC have the same length. So back in our picture here, we're saying this guy and this guy have the same length. Well, if they have the same length, on statement E here, it's saying then that B is the midpoint of AC. Well, how do we know that's true? Well, the definition of a midpoint says that they lie in the same line, it's in between the 2 endpoints, and it has the same length for both segments. So do we meet the definition of a midpoint? Well, yeah. So the reason we can state that B is the midpoint of AC is because it meets our definition of a midpoint. Okay, and then therefore B is the midpoint of segment AC. Okay? So we'll work on the other ones together in class, and then you also have the concept check, but this is the same idea as what we've seen before. We just have to draw upon what the knowledge we already know between our postulates, our theorems, and our definitions.